Hello everyone, I am Dr. Millie and you are watching Erudite Chemistry. In last lecture we have learned what is the nature of oxides, hydroxides and chlorides made by the second group element. In this video we will be learning the nature of salts of oxoacids made by second group element. But salts of oxoacid पढ़ने से पहले let us understand what are oxoacids and then only we will make the salt of these acids. Okay. So first of all let us understand what are oxoacids. This is the definition of oxoacids. Acids in which acidic proton मतलब the proton which is acidic means H तो है. That H if it is present in a compound it is not making it acidic. Any compound is acid just because it releases the H plus. तो acidic proton is that H which is releasable. तो acidic proton अगर होता है on the hydroxyl group, तो do remember वो acids जिनमें acidic proton is at OH, मतलब OH वाला H is going to be released. And with one more condition is there, and with at least one oxo group attached with the same atom. One oxo means O, double bond O. Oxo means double bond O, and one oxo group and one OH group has to be there in that acid. Then only that acid will be considered as oxo acid. I hope it is clear. करके देखते हैं. Let's take the example. I have one example here, that is sulfuric acid. All of us know that sulfuric acid is an acid. नाम से पता चल रहा है. So let's see whether it is an oxo acid or not. देखते हैं. तो if it is sulfuric acid, the structure of sulfuric acid is this: H2SO4. Can you see there? The conditions are being, if you apply the conditions, one hydroxyl acidic proton is present as the hydroxyl group. Look at this. This H and this H. These two H will be released by this sulfuric acid, and the condition was at least one oxo group should be there with the same atom, attached with the same atom. तो इसी sulfur के साथ we have two oxo groups connected. It means this sulfuric acid is an oxo acid. It is an oxo acid. Let's take one more example. देखिए nitric acid check करें whether this is an oxo acid or not. HNO3. So look at this, NO3. So look at this, HNO3. This is nitric acid. Nitric acid maybe you can see there, this acidic proton is connected with the OH, and this same atom to which OH is connected with the same atom, one oxo group is attached. More than one here in this case, but एक तो है. So this is why this is also an example of, it is also an example of oxo acid. Another example you can see, H2CO3. That is also an example. That is, we can have this example, COH. What is this? H2CO3, carbonic acid. H2CO3 में this is going to be released, this is going to be released. Acidic proton connected with hydroxyl group with the same atom, one oxo group is connected. Means this is also an example of oxo acid. Fine. Up when it will release the H plus ion, after that whatever is left out is known as oxo anion. So you know this thing, that when the sulfuric acid will be it will be broken down, it will give you what? 2H plus ion and one sulfate ion. So this sulfate ion is an oxo anion. Okay, look at this. This is going to give you H plus ion and nitrate ion. This is oxo anion. This is going to give you H plus ion and CO3 2 minus ion. This is oxo anion. So oxo acids dissociate to release proton and oxo anion. Now if you react these oxo anion, if you want to make the salts of these oxo acids, what will you do? You can react these acids with the metals. I am taking an example where I am reacting magnesium with H2SO4. You know this thing? This is minus, this is plus. So what will happen? This is plus, the replacement will be there. Because magnesium is more reactive, it will replace the hydrogen and will take the place of the hydrogen here and will make what is this salt? This is the salt of oxo acid. So what are oxo acids? Salts of oxo acids, the salts which are made by the replacement of H from the oxo acids by the more reactive metal. We get salts of oxo acid, or I can also say oxo anions with the metals make oxo acids ke salt. Okay, so this way we are getting oxo acids. I hope it is clear. So we are having oxo acids. These are the oxo acids, and these are the salts of oxo acids. And in this particular video, we will be understanding what is the nature of oxo acids of this group metals. Okay. So let's talk about carbonates and their behavior. We know this thing कि carbonates of the first group were easily soluble in the water. हम लोग जानते हैं that sodium carbonate, potassium carbonate, they were soluble in the water. इनके carbonates are not soluble. We are very familiar with the carbonate of this particular group. One carbonate we are very familiar, that is calcium carbonate. Remember that when we pass carbon dioxide into lime water, CaOH whole twice, and we pass carbon dioxide, they convert into CaCO3, which is a white colored PPT. So remember this precipitate reaction. This white colored PPT means they are not soluble in the water. So इससे हम याद रख सकते हैं that the carbonates of this group are not soluble in the water. And not only this, जैसे जैसे आप नीचे जाएंगे, the solubility of these carbonate will decrease. इसका मतलब क्या हुआ? ऊपर वाले carbonates के comparison में नीचे वाले carbonates की solubility will be lesser. Second thing is, when we talk about the heating of these carbonates, we all know this thing. When these carbonates are broken down, they are decomposed to give you oxides and carbon dioxide. So the carbonates of this group are heated to give oxides and carbon dioxide. But there is one carbonate of the first element, that is beryllium carbonate. This beryllium carbonate is so unstable, although all बाकी सारे are very stable. They decompose on heating only. They decompose on heating and then they give oxide and carbon dioxide. But this beryllium carbonate is so unstable that it is not stabilized in the normal temperature even. So we have to keep it in atmosphere of carbon dioxide. तो इसको रखने का तरीका है, we have to keep it in the carbon dioxide only, then only it will be saved. Otherwise this beryllium carbonate will be decomposed. So beryllium carbonate will be decomposed. It is easily broken down. It is unstable in nature. Rest of the carbonates will be stabilized, but when they will be heated, they will be broken down, will be decomposed into oxides and their carbon dioxide. सेकेंड थिंग इज द स्टेबिलिटी. अगर हम बात करें कि इनकी स्टेबिलिटी क्या होगी, द स्टेबिलिटी ऑफ देयर कार्बोनेट विल इंक्रीज अप टू डाउन. तो इनकी स्टेबिलिटी ऊपर से नीचे बढ़ती जाएगी. व्हाट डज इट मीन? इट मीन्स इफ आई एम गोइंग टू हीट द कार्बोनेट, लोअर कार्बोनेट विल बी हीटेड मोर. इट विल नीड मोर टेम्परेचर टू कन्वर्ट इनटू ऑक्साइड एंड कार्बन डाइऑक्साइड. ठीक है, तो नीचे वालों का स्टेबिलिटी ज़्यादा है, ऊपर वालों की स्टेबिलिटी कम है, बट दे आर स्टेबल. एक्सेप्ट दिस वन, दिस इज नॉट स्टेबल, दिस इज हाईली अनस्टेबल इन नेचर. ठीक है. नेक्स्ट थिंग इज इनके कार्बोनेट्स बनाए कैसे जाएंगे, हाउ दीज कार्बोनेट्स आर फॉर्म. तो डू रिमेंबर, मेटल के सॉल्ट्स को सोडियम या किसी के अमोनियम आयन के कार्बोनेट से रिएक्ट करा दीजिए आप. मेटल का सॉल्ट, आई एम राइटिंग डाउन अ जनरल रिएक्शन, मेटल सॉल्ट ले लीजिए प्लस ईदर सोडियम और ammonium carbonates. So you can easily form them. I am taking here one salt of magnesium, MgCl2, and I am reacting it with sodium के carbonate. What is that? Na2CO3. We know this thing, the affinity of the sodium towards the chlorine is more. So sodium is more reactive, it will take the chlorine, and magnesium will make the carbonate. So NaCl will be formed and MgCO3 will be formed. So this way the carbonates are formed. एक और example ले लेते हैं, BaSO4. This time I have taken the salt of barium and I am going to react it with ammonium salt, ammonium carbonate. So it is what? NH4 CO3. ठीक है. So this is what? Ammonium sulfate will be formed and barium carbonate. So NH4 whole twice CO3 and sorry, what will be formed? BaCO3 and ammonium sulfate will be formed. Okay, so this way their carbonates are formed. One more way is there to form their carbonates. इनके हाइड्रोक्साइड में कार्बन डाइऑक्साइड पास करने पर, so if you pass the carbon dioxide in their hydroxides, the carbonates can be formed. One more thing is there, if I continue pass the carbon dioxide in their solutions, that is carbonate में और ज़्यादा पानी डालने पर with and by passing the carbon dioxide continuously, means I am adding this CaCO3 may on passing carbon dioxide in the presence of water, these carbonates can be converted into CaHCO3 whole twice, means bicarbonates. And we know that these bicarbonates are soluble in water, very easily soluble in water, and that is why the precipitate are dissolved. So this carbonate is soluble, not soluble. It is precipitate and that is soluble in the water. So this is all about the carbonates and bicarbonates of this particular group. Group number 2, magnesium, calcium and all other elements. Okay, let's talk about the sulfates then. Okay, so I am starting with sulfate. Sulfate, again this is an oxoanion, sulfate SO4 2-. उसके बने हुए metal salts. These are sulfates. So इनका properties क्या होगा? We know this thing. These sulfates are white colored solid. हम सबने magnesium sulfate, calcium sulfate, we have seen them. These are white solids. Okay, these are white solid and they are very stable to heat. मतलब आपको गर्म करने पर they will be very stabilized and they will not be broken down easily to give you sulfur dioxide or something else. ठीक है. Apart from that, we have to learn BeSO4 and MgSO4. These two sulfates are very easily soluble in the water, easily soluble. Okay, these two sulfates are easily soluble in the water and their solubility, the credit goes to their very negative delta H of hydration. So actually they are very small. Inka delta H of hydration is very high, so that makes it very soluble in the water. The rest of the sulfates जो हैं, they are not soluble in the water. Means up to down when you move, the solubility of their sulfate decreases. So if I give you a list, that is BeSO4, MgSO4, calcium sulfate, strontium sulfate, barium sulfate. How the solubility changes means which will be most soluble and which will be least soluble. How can you arrange it? The most soluble will be this, and the solubility decreases up to down. So do remember, the solubility of this sulfate decreases up to down. और वैसे भी हम सबको ये तो idea है ही. We got the barium sulfate precipitate. We have learned this precipitate, seen this precipitate very nicely in our very junior classes, that is 10th May. Many times we have got the sulfate of barium sulfate precipitate. So that is very good precipitate, means it is not soluble in the water. Solubility decreases up to down. And magnesium sulfate is soluble in the water. Credit goes to very negative hydration enthalpy. Why? The reason is very small size of the magnesium ion. I hope it is clear. इसके अलावा if I go for the thermal stability, okay, ये तो हुई solubility. थर्मल स्टेबिलिटी की अगर हम बात करें तो थर्मल स्टेबिलिटी ऑफ दिस सल्फेट ऑन मूविंग अप टू डाउन क्या होती है? ये इंक्रीज करती है ऑन मूविंग अप टू डाउन. तो ऑन मूविंग अप टू डाउन थर्मल स्टेबिलिटी इंक्रीजेस. मतलब क्या होगा? Barium sulfate will be most stable and this will be lesser stable. So when we move up to down, the thermal stability increases, बढ़ती जाएगी. So these compounds will be more stabilized and this will be least stable out of these sulfates. So in the second group, the stability, thermal stability on heating, how they decompose, that changes. Na? So how they decompose on heating, that changes up to down. It increases, stability increases up to down. So this way the sulfate behave. So let's talk about the nitrates and how they behave. But before that, you are given the preparatory method of the nitrates also. So let's take it first. If you want to make the nitrates, you have to take oxides or hydroxides. What you are taking? You can take oxides and hydroxide, or you can take carbonates also. And these you can react with what? यानी कि आप salt लेंगे and then you are going to react them what with nitric acid and you can get the nitrates easily. मतलब oxides, hydroxides and carbonate की reaction nitrates के साथ nitric acid के साथ कराने पर you can get nitrates. Let's take one example of this kind. I am taking oxide, calcium oxide. I am reacting it with nitric acid, HNO3. What will be formed? Calcium nitrate, CaNO3 whole twice plus H2O, H2. ठीक है. Next is if I am taking carbonate, CaCO3 plus nitric acid, CNO3 whole twice and H2O. ठीक है. H2O plus CO2. What is that reaction? In this reaction you can see carbonates and bicarbonates react with the acid to form salt, water and carbon dioxide. It is that reaction. तो carbonates के साथ ये बनेगा. Hydroxide देख ले. One example of hydroxide I am taking what? BaOH whole twice. इसकी reaction किसके साथ करें? It is reacting with HNO3. क्या बनेगा? क्या बनेगा? BaOH whole twice hydroxide with carbonate. What will be formed? BaNO3 whole twice plus H2. This will be formed. So you can easily form their nitrates using oxides, hydroxides and carbonates. So let us talk about how they decompose, whether they decompose on heating or not, or how they decompose, how their stability changes. So if I talk about the decomposition, the nitrates decompose to give you the nitrogen dioxide and oxygen. For an example, if I decompose magnesium nitrate, MgNO3 whole twice, on heating it decomposes to give you oxide, nitrogen dioxide and oxygen. So this is MgO will be formed, NO2 will be formed and oxygen will be formed. So this way these two gases will be formed. अच्छा, second thing is that जो lower nitrates हैं, they cannot be decomposed easily. Means the stability of these nitrate increases up to down. So if you want to arrange the nitrates in order of their increasing stability, how you are going to arrange? Magnesium nitrate, if you are given MgNO3 whole twice, you are given CaNO3 whole twice and you are given BaNO3 whole twice. Which out of these will be more stable? So you will use this thing. That is up to down. When we move, the stability of their nitrate increases. Means they can be decomposed easily on heating simply at the lower temperature. But these high nitrate cannot be decomposed that easily on heating at the lower temperature. They need more energy to be broken down. Is it clear? Second thing is their nitrates are hydrated in nature. ठीक है. और जो upside elements हैं, the tendency of the upside element to make the hydrated nitrate will be more, and when we move up to down, the tendency to make hydrated molecule, hydrated compounds will be lesser. The reason is that hydrates are formed by the smaller cation. So smaller is the ion, easier will be the hydrate formation, and that is why smaller nitrate, the nitrates of the smaller atom makes the hydrate and lower side element does not make hydrate. So this way the tendency changes. For an example, magnesium nitrate exists as MgNO3 whole twice, exists as MgNO3 dot 6H2O. जबकि आगे जाते जाएंगे तो बेरियम नाइट्रेट BaNO3 it does not exist in the form of hydrated molecule. तो ये तो hydrated molecule की तरह exist करता है. How it exists? It exists as anhydrous molecule. Okay, so this way their tendency changes. I hope this video will help you to understand many concepts. If you like this video, please hit the like button. share it and subscribe my channel. Thank you very much.